Good morning, guys. Today we are going to be continuing, I should say, with quadratics, and we're going to be graphing quadratics for the next few lessons. All right. So today we're going to briefly talk about the basic shape of a quadratic. All right, and then we're eventually going to graph it in three different ways. Today we're just going to do one way, which is going to be vertex form. And then you're going to have just a worksheet for homework to do in class, depending how long this takes. And then tomorrow we will do the next two ways. All right. So first off, before we actually talk about how to graph a quadratic in vertex form, what is a quadratic? All right. So quadratics, basic shape here, basic function y equals x squared. All right. So when we have a exponent of squared, all right, that's going to be a quadratic where the highest exponent is 2, all right, and what the shape of this looks like. So to graph this, the basic shape here, we're just going to plug in some points, all right. This is not how we're going to graph it once we know what this looks like, all right, but anytime you're not sure what something looks like, any function, you can always just plug in some points and see if you can figure it out from there, all right. So first, let's just start. If I plugged in 0 for x, right, it'd be 0 squared, which means I would get 0 for y. All right, so that would be at 0, 0 right there. All right. Now, my next point, let's put in 1. If I plug in 1 squared is 1. So that's 1, 1. And if I plugged in -1, I would also get a +1. All right, so I get 1, 1 and -1, 1. All right. Then if I plugged in, let's say 2 and -2. So if I plug in 2 and -2, 2 squared is 4, and so is -2. All right. So I plug in 2, 2 squared is 4, and -2 is also 4. All right. So in case you did not know before, the basic shape of a quadratic is a parabola. All right. It looks like a U. All right. And we can keep plugging in points, but this is the basic shape of a quadratic. All right. Now, a few things I want to point out about this. All right. This point here, 0, 0, this is what we call the vertex. All right. This is the vertex. All right. This is where the bottom is, or it could be the top, depending on what it is. So vertex of a basic shape is 0, 0. Now, notice how when we plugged in 1, we got 1, but also -1, 1. All right, these points are equidistant away from what we call this imaginary line that I'm drawing down here. All right, that is called the axis of symmetry. All right, in this case, the axis of symmetry is x equals 0. Right, it's going right through the middle. The axis of symmetry will always be the x coordinate of our vertex. All right, and this is going to move around when we do these shapes. It's going to keep moving, but notice that this point here is the same distance away from there. This one here is the same there from this distance here from the axis of symmetry. All right, this parabola is facing up. All right, so we would say that this parabola has a minimum value. All right, we'll talk. If a parabola faces down, it will have a max. All right, this one has a min because it's facing down. Sorry, it's facing up, which means it has a minimum. This one is facing down, so it has a maximum value. The max and min value is always found at the vertex, and it's the y coordinate of the vertex. Once we see some other examples, you'll see that. Now, if we talk about domain and range, D for domain, R for range. The domain is all the possible x values. Well, in this problem, x can be anything, right? It's going to keep going over. I can plug anything for x, and it gives me something for y. There's no restrictions on it, all right? So that means it's -infinity to infinity. And that's always going to be the case for a parabola facing up or a parabola facing down. It's always going to be -infinity to infinity. The range, well, there's nothing down here, right? So it does that is not negative infinity to infinity. So you go to what the minimum value is, or to the vertex. You take the y-coordinate of the vertex, which is, this case is 0. It is in brackets because it can be equal to 0, and it goes up forever. So it would be 0 to infinity. All right. So important points here are the vertex and then these other things. So now to graph when we graph, we are going to graph using 3 points. All right. We're going to need a vertex and 2 other points. And the first form we're going to talk about is vertex form. All right. Vertex form, it's called vertex form because it's very easy, shockingly, to find the vertex in this form. All right. This right here is the vertex form of a quadratic. All right. So we have a few things here that are important, and we're going to start off with the vertex. All right. So y equals a times the quantity x minus h squared plus k. All right. So the vertex, the h, this value here is going to determine our x coordinate of a vertex, right? X coordinate. This k, this value outside of the parentheses, outside the quantity squared, is going to give us our y coordinate of the vertex. So when a quadratic is in vertex form, it's going to be very easy to find the vertex by just looking at the equation. Okay. Now notice how it's x minus h, but this is a positive. So basically, whatever makes this equal to 0 in the parentheses, that's going to be our x value. This number out here, if it's positive, this is positive. If it's negative, this is negative. All right. This a determines a few things. This tells us the direction that the parabola is going to be pointing. All right. If a is greater than 0, meaning positive, it's going to face up. If a is negative or less than 0, it's going to face down. All right. This number is also going to tell us the width. A is also going to tell us the width of it. All right. Our normal, if it's just equal to 1, which we have in the previous problem in our basic shape, right? In our basic shape, there is no number in front of x squared, so it's just 1. When a is 1, we call that normal width, or sometimes called standard, right? Normal or standard. But if the absolute value of a, so the reason I said the absolute value of a is because it doesn't matter if it's positive or negative. The positive or negative determines up or down. But in terms of width, you're just looking at the absolute value. If it's larger than 1, all right, then it is more narrow than the original. And if it is less than 1, then it is wider. All right. That W is not that great. That's supposed to say wider. Okay. All right. So, and I'll refer back to this several times as we're doing these examples. Okay. All right. Now, so if we look at this first example of y equals the quantity x minus 3 squared plus 1. All right. So x minus 3. So we want to find the vertex. So we look at this, and x minus 3, remember that's h, is going to be our 3. What makes this equal to 0? Well, 3 makes it equal to 0. So 3 is going to be the x coordinate of vertex. This is my k, which is my y coordinate of the vertex. So that is 1. So my vertex is at 3, 1. All right. So you can put slash marks, or you can just literally put a point at and label it 3, 1. Now, to get the other points I need on a parabola, so that's my vertex. I need one to the right, one to the left. Well, guess what's going to tell us that? A is going to tell us that. All right. So in this problem, there's nothing out in front. So our A is equal to 1. That is how much I'm going to go up or down. All right. I'm always going to go up or down that much. Since it's positive, I'm going to move up. And first of all, I can't label. Sorry. This 3, 1 is right here. Sorry. I'm going to go up 1. You will always go to the right and left 1. So my new points are going to be there and there. So you're going to go up or down A. So whatever A is, that's how much you're going to go up or down. If it's positive, you go up. If it's negative, you go down. And we are always going to the right and left 1. RT for right. All right. So since A was 1, I went up 1 from here to the right 1, put a point, went up 1 to left 1. And there it is. You just make a parabola right there. All right. And those are my points. So that was at 4, 2. All right. That's at 2, 2. And this point was the vertex, which was 3, 1. All right, so if I wanted to do my domain and range, my domain, all right, is negative infinity to infinity. Any parabola facing up or down is always negative infinity to infinity. The range, all right, starts down here with the y value, which is 1, and goes to infinity. All right, this has a minimum value at, so the minimum value, since it's a parabola facing up, has a min, right? It's not a max. There is no max. Max is infinity. All right. The min is at 1. It's always the y coordinate of the vertex. The axis of symmetry for this problem is always where the x coordinate of the vertex is, in which case is 3. So x equals 3 is the axis of symmetry. All right. All right. Moving along to the next example. All right, so y equals 2 times the quantity x plus 4 squared. So let's find my vertex. Well, this helps me find my x coordinate, set that equal to 0, which is negative 4. So my vertex is at negative 4. Just set that equal to 0. And I get negative 4. So that's my x coordinate. Now, notice there's nothing here. So my y coordinate is 0. So negative 4, comma, 0 is going to be my vertex, negative 4, 0, right there. All right, now to figure out my other 2 points, what's my A? My A is 2, all right? So my A is 2, so I'm going to go up 2 to the right 1, to the left 1. And there is my, graph those points, and there is my parabola, all right? So we're at negative 3, comma 2, negative 5, comma 2, and then we have my vertex, which is at negative 4, 0. All right, so the domain, once again, is negative infinity to infinity. The range, once again, we have a minimum value. The range is from 0 to infinity. All right, now if I ask, so this graph is considered more narrow than the original, because normally we go up 1 to the right 1. Now we're going up 2. And you can see the more you go up, so for instance, if I had like 10, the reason that is considered narrower, because if I went 1, 2, 3, 4, 5, let's say 10, comma 1 be here, right? Then I always go to left 1. You can see how that is going to be a much more narrow graph compared to my other one. All right. Whereas if A is less than 1, let's say it's at like 1/2, if I go up half 1 to the right 1, you can see where that graph is much wider. All right. So that's why when A is greater than 1, it's narrow. When it's less than 1, it's wider. All right. So our first example was normal because it was A was just 1. Our second example, it was more narrow because it was larger than 1. All right. This also has a minimum value, and the minimum value is 0 because it's always the y coordinate of our vertex. All right. So for 3, all right, use those numbers. What would our vertex be here? Well, the vertex, set this equal to 0. We get 1, comma, whatever this number is here, which is positive 2. So 1, comma 2 is my vertex. All right. 1, 2. All right. So I put 1, 2, label that. Okay. Now we have A that is negative. So now is our first time we are going to go down. Now, do not go down 1 and the right 2. Do not treat this like slope. We always go to the right and left 1. We go down this amount. So we're going to go down 1/2 to the right 1. We're going to go down 1/2 to the left 1. Now, this is where, obviously, you can't tell if it's exactly half, but you have to just label your point. All right, so this is at 2 comma 1.5. I'll just call it 3 over 2. All right, and this is at 0 comma 3 over 2. All right. So the range of this is still negative infinity to infinity, but now we have what we call a max value because we have a parabola facing down. We have a max at, and it's whatever the y coordinate. We have a max at 2, which means now it's from the range is from negative infinity to 2. All right, it's pointing down, so we always go bottom up when we're doing the range. So it's negative infinity. The maximum value is at 2. That's the highest that y can be. Range has to do with y values. Domain has to do with x. All right, this points down. This is a wider parabola because we have 1/2, which is less than 1. All right, the axis of symmetry is at 1 because it's always the x coordinate of the vertex. All right. All right, let's do one more. We'll call it a day. All right. So, all right, looking at this, what do you guys think the vertex is going to be? Looking at this example, 1/4 x squared minus 1. All right. Well, there's nothing in the parentheses with x squared, which means what makes that equal to 0? 0. So the x coordinate 0, whatever's off to the right, that's your y coordinate. So it's 0, comma, negative 1. All right, 0, comma, negative 1. All right, so I'm going to put a point right there, 0, comma, negative 1. It's 1/4 is a, which means I go up a quarter to the right one, go up a quarter to the left one, not up one to the right 4. That is wrong. All right, it's not slope. It's not linear. It's quadratic. All right, not the greatest parabola in the world, but it is what it is. So I labeled this point. It'd be 1, comma, negative 3/4 because I went up a quarter from negative 1. And this would be negative 1, comma, negative 3/4. All right. The domain, once again, as all of these have been, is negative infinity to infinity. The range, this has a minimum value. So we're going to make that a bracket. It should be a bracket, sorry. And whatever the y coordinate of the vertex is, in this case is negative 1. So you go from negative 1, it's pointing up, negative 1 to infinity. This graph is wider than your normal graph, the basic shape. All right, it's pointing up. All right, so you can tell a lot of information by just looking at an equation once it's in vertex form. All right. All right. Hope you guys understand. What any questions you guys have, I can clear up when I'm back in school tomorrow. And I'm going to give you guys will have an assignment, a worksheet where you have some graphs and answer some questions. I will include the answer key so you'll know right away if you're doing this correctly or not. But please try to obviously do them on your own first before you check the answer key. All right. Hope you guys have a great rest of the day, and I'll be talking to you soon.